Y sin más preámbulo, demos inicio con nuestra primera conferencia del día, titulada Reacondicionamiento Inmobiliario y BIM, a cargo de la doctora Elizabeth Hausler, PhD, fundadora y CEO de Build Change y experta global sobre vivienda resiliente. Elizabeth nos dará a conocer cómo BIM ha sido un aliado estratégico en el desarrollo y avance de los proyectos de Build Change en la mejora de viviendas sociales consideradas como vivienda informal. Pero antes de darle la palabra, les quiero recordar a las personas que requieran el servicio de traducción simultánea, hacer clic en el botón traducción que se encuentra en la parte inferior central de la pantalla. Y ya saben, en caso de que no funcione inmediatamente la traducción, por favor refrescar la página. Doctora Elizabeth, gracias por aceptar esta invitación. Adelante con su intervención.
My pleasure. Thank you so much. I'm so thrilled to be here. What an honor to speak with all of you today. I'm Elizabeth Hausler. I'm the founder and CEO of Build Change, and I'm thrilled to be talking about BIM and social housing. All right, so I need to share my screen. All right, here we go. Okay, let's see. So I want to start out with a video which shows very clearly and eloquently what Build Change has been working on in Colombia.
Build Change es una empresa social sin ánimo de lucro. Nuestra misión es prevenir pérdida de vidas humanas y pérdidas económicas en desastres naturales, sobre todo en vivienda y en edificaciones escolares. El escenario de Medellín y del resto de Colombia tenemos una densificación importante en las últimas décadas de la vivienda informal y que casi nunca cumple con la norma actual vigente de la construcción. Es decir, son viviendas que normalmente presentan deficiencias en sus estructuras y carencia de capacidad para resistir eventos naturales como un terremoto.
Mi nombre es Noelia Rosa Torres Barrientos. Nos encontramos en el barrio El Picacho, donde vivimos. Posiblemente más adelante puede que hayan como sismos. Entonces el objetivo es que la casa resista a esos sismos.
Hay estudios en el mundo que demuestran que reforzar una vivienda cuesta 5 o 6 veces menos que reconstruirla después de un terremoto. En particular en Colombia, reforzar una vivienda de tipo informal cuesta en media un 30% menos que construirla nueva. Pero también guarda a las familias de sufrir un shock debido al desplazamiento, al tener que empezar una nueva vida en un nuevo lado de la ciudad.
Mi nombre es María de J. Ortiz. Yo vivo en el barrio Santander. Yo decidí hacer eso porque mi casa se estaba cayendo. Entonces ellos están haciendo eso como para que tenga seguridad y que ya no se me vuelva a tarjar como estaba y que ya no se me va a volver a caer. Yo estoy muy contenta porque en realidad las personas me han apoyado muy bien, tanto pues los de la acción comunal como ustedes. Todos se han manejado súper bien conmigo.
Bueno, esta experiencia del reforzamiento de la casa ha sido maravilloso. Yo no pensé que le metían tanto amor a lo que ustedes hacían. Yo pensé que era simplemente, bueno, vamos a hacer columnas y ya no, es mucho más y está la calidad humana.
Pues ya sí creí que era la verdad, que no estaba soñando, sino que era la realidad.
Es muy lamentable tener que reaccionar después de un desastre. Para comenzar, el costo de la vida no tiene precio, o sea, no hablemos ni siquiera de cuestiones económicas. Estar levantando muertos en algo que pudimos haber evitado, pues no, yo creo que no tiene excusa. Estamos ya en un punto en Colombia y en América Latina en el que conocemos la tecnología, tenemos la capacidad técnica, inclusive tenemos alguna capacidad financiera para superar estos problemas. Hay que empezar a entrarle al tema de una manera responsable.
Poder ver ahora cómo las familias son conscientes de la importancia de trabajar en temas como la prevención del riesgo, nos hace sentir muy orgullosos de todo ese esfuerzo y todo ese empeño que hemos realizado durante todo este tiempo.
Se ve que lo que hacen lo hacen con amor y realmente saben lo que están haciendo.
Thanks again so much, everyone. Really honored to be here and to enable more homeowners like Noelia and Maria in Colombia and around the world to access resilient housing. Once again, I'm Elizabeth Hausler, the founder and CEO of Build Change. Build Change is a nonprofit social enterprise that works to enable folks to have access to disaster resilient housing around the world. Here are just a few of our impact numbers. Over 93,000 homes and some schools are safer throughout the world, and we have served over 600,000 people who are living and learning in safer buildings. So it is possible to strengthen existing housing to withstand disaster. This is Build Change's mission, and this is what we have been doing in Colombia and beyond. Improving existing housing is something that costs less than building new. It also has a lower environmental footprint. We can save carbon impact and impact on the environment by strengthening housing before disasters. Here are just a few examples of some of the homes Build Change has retrofitted around the world, in Nepal, in Colombia, in Guatemala, in Haiti, and in other countries. It also preserves the homeowner's investment in a disaster resilient home and enables other improvements that improve folks' daily lives. Recently, we released the Build Change Guide to Resilient Housing. Please feel free to access that through our website, buildchange.org. We've got a QR code here if you can quickly scan that. It is a very useful resource that not only provides philosophical background on how we look at the resilient housing problem, but also actual case studies where we've implemented resilient housing programs around the world. It's a handbook that is intended to be useful for governments as well as implementers to implement and scale resilient housing programs around the world. So I encourage you to take a look at that. Now, how do we approach the challenge and opportunity of resilient housing? Let me give a bit of an overview about how Build Change works. We simultaneously overcome the three barriers to adoption of resilient housing: people, money, and technology. On people, someone has to want housing to be safe and healthy. That could come from the homeowners or from policy change and political leadership. We have partnerships now in Colombia at the neighborhood, city, and national levels, and have been successful in bundling home improvements, upgrading kitchens and toilets, as well as improving security and fixing leaky roofs. These elements are important to the daily lives of residents, and they create demand for resilient housing. So on financing, we often think about money or financing as essential to build a resilient house, and that has to funding is needed in three main buckets: money for the materials and labor, money for program implementation, and then money for systems change or policy advocacy. And third, technology underpins it all, and that's really what I want to talk with you about today. We need BIM tools to make everything efficient, as well as information platforms so that projects supporting resilient housing can scale. So we need to simultaneously overcome all of these barriers to adoption of resilient housing: people and policy, money and technology. But what I most want to talk to you about today is the technology part and how we can use BIM tools as key to scale. All right, so this is a very simple overview of the workflow for resilient housing home strengthening projects. It's a very simple overview. First, it starts with data collection in the field, data about the homeowner and about the condition of the house itself. An important piece of gathering of this is gathering data about the house's floor plan, as well as other information, so an accurate Revit model can be constructed. The second step is using all of this data collected to perform engineering calculations and come up with a retrofit design. Then a construction package is developed, which contains all the necessary construction documents, including floor plans, construction details, list of materials, bills of quantity, as well as the cost. And these steps, after all these steps are produced, a construction can begin. So now, in the early days when Build Change was first starting out, these first 3 steps took 9 days. So 9 days to collect the data in the field, to put it into a spreadsheet, to use an AutoCAD 2D drawing, to do the calculations, to develop the construction package. Now, if we're thinking about thousands and thousands of homeowners in Colombia and around the world who need access to a home improvement to strengthen their house to withstand disasters, that is not going to scale. So yes, in those early days, we used these tools. We used hand sketches, we used AutoCAD 2D, we used Excel, and we eventually incorporated Revit. But these are very time-consuming manual steps in order to complete the process. So I want to show you an example of a basic implementation of BIM tools we did in one of our earlier programs. This is in Nepal. So data would be collected by engineers on site in the field, measuring details of the house, and then creating a hand sketch. You can see an example here. Data would be gathered in the field, trained engineers and architects going to the site and capturing all the data that they could about the house, the floor plan, where are the structural deficiencies located in the building, and the overall condition. After that, a drafter would then have to interpret this data, interpret this hand sketch, and translate it into a Revit model, a process which left a lot of room for error, and also it consumed a lot of time in that sometimes the Revit model was different than the existing conditions. Then from here, an engineer would need to use the Build Change design manual and a series of Excel spreadsheets to generate a specific retrofit design catered to that specific house. After the design was created, it would need to be applied to the existing Revit model to represent the retrofitted house. After construction, from here, final construction documentation and the construction package could be collected. But there's a lot of steps here, and all manually done using one system to another system to another system. So, but eventually, even with these advances from AutoCAD 2D, which we were using in the early days, to Revit, which you can see here, the process was still very manual. Here you can see one of those implementations of a final retrofit model after the 2010 earthquake in Haiti. So we first adopted these tools we first adopted Revit in Haiti, and our first attempt was again very cumbersome and very manual. We went from an existing model to a Revit model to the construction package, and in the end, these are quite useful tools, but it took a very long time to get to this point. These are some of the bottlenecks in this process, everything from collecting data into the field, hand sketches being recorded, manual modeling of an existing house in Revit, to analysis and design done by the spreadsheets, to the production of the retrofitted design. So many steps in the process and a lot of opportunities for error. So we asked ourselves, wouldn't it be better if this process was automated, if this process was much more efficient? So fast forward to, so we then began automating designs in Revit with Dynamo. Dynamo is a very critical tool here that allows us to program in the design checks. So we first explored this in our Nepal program after the 2015 Gorkha earthquake, where we used the visual programming interface within Dynamo and tested that for the first time to determine if it was a useful way of automating the retrofit design process. The typology of housing in Nepal lent itself to this process because most of the houses were the same. They were similar 2 or 3 story stone masonry, rectangular shaped buildings with similar patterns of windows. So same building materials used over and over again. So these similarities allowed us to come up with a type design for retrofitting that could be applied to many thousands of houses that fit the same criteria. And here's a quick snapshot of how it works.
Assessments. Structurally retrofitting a building typically involves strengthening it from within by connecting a series of reinforced concrete columns and beams to the existing walls and structure. Prior to this, however, we typically have to do an analysis of the existing home to ensure assessments.
So by using prescriptive design, by basically creating a set of design rules that we can apply to each building, we're able to eliminate intensive structural engineering for each house. We do it up front and we create a set of rules that then we're able to check with each home. This expedites the process significantly, and we are able to reach more homeowners with solutions. So here's, for example, one rule check we would evaluate is the length of the house and where columns should be located. We place columns at specific spacing based on that length and a variety of other factors. Another rule check was to evaluate the height of the walls and the thickness of the walls to place a ring beam on top of them. So these are very simple rules that we can develop based on structural engineering analysis as well as geometry of the building. So the engineering methodology was adapted to suit the technology. When the engineering rules were simplified to a series of yes or no statements, then these checks could be easily programmed into Dynamo. And this next one shows an animation of that process. It's an example of a dynamo workflow that we developed based on a type design in Nepal called the split and bandage retrofit method. This method aims to reinforce the openings of the house with reinforced plaster in splints on the sides of the openings and bandages on the tops and bottoms. So you can see, I'll play it again here. Oops. So you can see how quickly it moves through these checks. We've got a Revit model that has been developed based on an actual house, an actual design, and then we've got a set of checks that are done in order to design a retrofit. In just a matter of like 17 seconds here, we can run through these checks, we can design the retrofit, we can put in the ring beam or the splints and bandages that need to be implemented, and we can come up very quickly with the design, with the bill of quantity, and with the cost. This is an outstanding step forward in terms of using BIM tools to automate structural retrofitting of existing housing. You know, when we started, I think people thought this was going to take forever because every house was different. But if you group like houses together, which are the same, and come up with a prescriptive yes-no way of evaluating the building, then this works extremely effectively. All right, so remember our workflow, which in the beginning I said these first 3 steps take about 9 days. This process using Revit and Dynamo scripts, we've reduced to 3 hours. So from 9 days to 3 hours, it's a huge increase in efficiency, and it can be applied, again, in many neighborhoods with many different types of housing around the world. All right, so this is an example of an actual house that we strengthened in Nepal, as well as the Revit model of the strengthening solution. And let's see, we also have a virtual reality experience. Let me switch here to that. So we also created a virtual reality experience so people could experience what a retrofitted house looks like. This is again in Nepal, and what we have here is a home that was strengthened after the 2015 earthquake. You can enter the building. You can look around at the strong backs that were used to reinforce the house. You can go upstairs to the second floor and look at what was done. Strong backs reinforcing the walls, ring beam, and new roof. And the beauty of this, or one of the beauties of this, is that you can actually click on the Revit model and see the model. So this is the model that I'm showing now, right? So we can see both the actual building and the Revit model of the home. It's an exciting way to communicate not only to homeowners about what will happen to their home during the retrofit process, but also to stakeholders at large. The potential of this tool is truly enormous. So let's go back to the main presentation. All right. So now we have the opportunity to accelerate design of housing retrofits in Colombia using these tools, using this combination of automation through Dynamo and Revit, as well as improvements on other steps of the construction value chain. So can we innovate? We've been innovating on the design and construction process, but can we innovate on some of the other steps of the process to make it even more efficient? Can we innovate on data collection in the field, as well as the other steps of the process? So we can do that using other tools for other automated tools. So we have applied Fulcrum and Magic Plan for streamlining data collection. Fulcrum is an application for designing custom smart forms, and it's used by Build Change to collect a wide variety of data on the house as well as on the homeowner, including demographics of people living in the houses, data on the structural vulnerabilities of the house. It also allows us to capture photo and video of each house and have that data stored in a convenient location. It can also be accessed by government partners and other partners. It's a very useful tool that can be customized to the application. Like I said, collecting a wide variety of information that is necessary to implement home improvement projects. Magic Plan is an app that's also important to our BIM workflow because it allows users to draw floor plans on the house accurately. Remember, we used to do these by hand, but moving away from that and being able to implement an app that does this much more effectively has less opportunity for error, more efficiency, reduction in time and cost, and so on. So we use then the floor plan capture as a way of expediting the input of data from the app, from Magic Plan into Excel, which then can be run through the Dynamo process, as well as then producing the Revit model. So we can eliminate the time we need to manually draw the model in Revit by uploading directly from Magic Plan. So it enables us to cut many steps out of the process. Once a house is drawn in Magic Plan, it's uploaded to our Columbia workspace. From there, all the user needs to do is to create a new project in Revit and then run our template run our import scripts using Dynamo. And then these scripts can access Magic Plan workspace and allow you to choose the house you want to import, and then translate to the Excel file. So all of this data, all of this process is now, I wouldn't say fully automated, but at least partially automated, reducing the time and reducing the cost. So here's an example. This is a demo of an import process that we showed in a previous presentation at Autodesk University. It illustrates the process of importing that data from Magic Plan, importing that floor plan, and importing it into Revit. So first, an engineer went to the field, drew the site in Magic Plan, and then imported it into Revit. So here it ends up being an exact replica of the home. And we don't need to draw it again when it comes to the retrofit solution. So we can use the same information and the same model to implement the retrofit solution and cut the work in half that way. All right, so I want to talk a little bit about automating the design process, right? Because we've talked about making everything more efficient, but how can we say, well, we can do the structural design the structural engineering up front and then automate it? So this has been and something that Build Change has done since the very beginning, doing new construction as well as retrofit. We can simplify structural design into a set of design rules. For example, we can say things like, if we are missing plaster, we can add plaster. If we are missing a ring beam, we can add a ring beam. So we can ask very simple questions about the presence and absence of structural elements and then input a solution. Then we can also automate decisions about the placement of columns and windows and doors based on simple geometry. So, and we program all of this in Dynamo, and it does the work for us, which is an outstanding opportunity for efficiency and scale. So inside a Dynamo script, it actually looks quite complicated. I'm not expecting you all to be able to read what this diagram shows. But again, once we get a very clear, powerful opportunity here with this visual programming environment, it allows us to automate these functions in Revit. Inside a Dynamo script, first geometry is taken from Revit and then passed through several conditional statements that allow the script to place Revit elements according to its analysis. So a fantastic opportunity and a superb tool if well developed for scale. All right, so then in the end, we have a complete retrofitting workflow that takes us from collecting data in the field to producing the design and construction documents we need in order to strengthen a home. So I'll play one last animation here. This is the run through of a complete retrofitting workflow. There are 13 scripts in total that the house goes through, in this case, to be retrofitted completely. So 13 checks. And as you can see with the progression of each script, Revit elements are added to the model. It's modified according to the rules programmed into the script. This process results in a completely retrofitted model that is retrofitted according to our design manual using this prescriptive design approach. There's some limited human interaction required through this process, which really allows us to speed up the process and allows users with little Revit experience to execute the workflow. So we don't need someone with a master's degree in structural engineering to run this. It can be run by those with less experience. At the end of the script, which we're getting to, you will note that this final script produces a bill of quantity and detailed production guidelines and assemblies, and the house, so it produces a bill of quantity as well as construction drawings and specific construction details for that particular house. And we can put those into a design library in order to use those in the future. So not only does this process result in a final retrofitted model, but it results in a comprehensive construction package specific to that house. It's just amazing what we can do with these tools now. And I encourage you to use them and experiment them and reference some of the other presentations and resources that Build Change has available. All right, on my final note here, we're not quite done yet. It's now running the check on the gable walls, so we're nearly done. We're on check 11. Parapets, and now we're running the bill of quantity and producing the details. All right, here we go. So the bill of quantity is complete, and we've got our detailed drawings. It's just magic. It's like magic. So it's a wonderful tool. And again, it can be developed to roll out reconstruction, retrofit options at scale for similar types of homes. So wrapping up here, we need to mobilize people and policy, money and technology in order to retrofit and strengthen housing at scale so that everyone has access to a resilient home. We now have shared with you an efficient workflow for addressing existing housing, which also pairs with Build Change's manual for reducing the vulnerability of existing housing. This is an upcoming IES document, IES 410, which is under final review now. This should be available for all engineers to use. So coupling this new manual with BIM tools can create access to resilient housing for everyone. Thank you so much for the opportunity to speak with you today, and I hope you enjoy the rest of the day.